Today's question is about negation. And what negation means is, if you take a statement, then the negation of it is what it means if this statement is untrue. So if you have some statement, blah, 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 then the negation of it is blah, blah, blah is not true. Or another way of saying that is blah, blah, blah is it is not true, whoops, that blah, blah, blah. So when you're thinking about these statements that you're trying to negate, that's what to think about. It's also what you would have to do to prove that something wasn't true. So let's just look at a few of these statements. There are ways that you can negate things by rote when you see certain for alls and exists going on. So the first one we've got is for all x in R, x times 0 equals 0. So how do you negate this? You turn the for all into an exists. You stick in a such that, and then you take the opposite of the final statement. And the opposite of x times 0 equals 0 is x times 0 does not equal 0. And so now if you just think about this, that's how you do it by rote. Now if you just think about it logically for a second, what this is saying is, it is always true for all x in R, x times 0 equals 0. So what would you have to do to prove that that wasn't true? To prove it wasn't true, you would just have to find one x for which it wasn't true. That is, that there exists an x such that x times 0 is not 0. And so you get the negation. And in this case, this was there exists x such that, oh, it's b. Right. Okay, let's try the second one. Second one is there exists x not equal to y in the ring such that x, y equals 0. Now let's do it by rote first. To negate this with a for there exists, you start by turning the exists into a for all, right? And then we have for all x not equal to y in R. Then you get rid of this such that, because it doesn't make any sense anymore, and then you negate this last bit, which is x, y equals 0, and the opposite of x, y equals 0 is x, y does not equal 0. So that's how you do it by rote. Now let's see what we're actually talking about here. We're saying there exists some x and y that are not equal to each other, such that x, y is equal to 0. And so what would you have to do to prove that that wasn't true? To prove that there did not exist any such x and y, you'd have to show that for all such x and y, the thing wasn't true. That is that for all x not equal to y, x and y is not equal to 0. So that is D. If you're wondering about the sense of this statement, I will concede that this statement is not a very sensible condition to have on x and y, but you can still negate a statement even if it's completely untrue, or even if it's stupid, you can still negate a statement. The one famous one the philosophers like is the moon is made of soft green cheese, which isn't true. Oh no, there's a better one than that. Something about dreams, sleeping, fearful. I can't remember. Right. Right. Number 3 was x is in R implies that 1 times x equals x. Okay? So how do you negate this? Well, first you think to yourself, another way of saying this is for all x in R, 1x is x. So another way of saying this is for all x in R, 1 times x equals x. And now if you can negate that, you turn this for all into an exists. And then you negate this, you take the opposite, so you get 1x is not equal to x. And that exists x such that 1x is not equal to x is f. So the first 3 were B, D, F. Now let's try 4, 5, and 6. Four, 5, and 6. Question 4. Question 4 says, for all x equals y, x, y is equal to 0. Oh, was this where I was trying to catch you out? Possibly this is where I was trying to catch you out. So to negate this, you need to turn the for all into an exist. There exists x equals to y in R, such that, and now you negate the last part, which turns into x, y is not equal to 0. Now let's just think about this for a second. The first statement is saying, no matter what x and y we have that are equal, x, y is always 0. Pretty stupid, right? So if you negate that, all you have to do to prove that that's not true is exhibit one example of an x equal to y such that x, y is not equal to 0. So here we are, there exists x equal to y such that x, y is not equal to 0. And if you look this up, there exists x equal y such that that's E. Okay, number 5 was there exists x in R such that 1x equals x. So to negate it, you turn this exists into a for all, and you negate this part so that 1x is not equal to x. Think about it for a second. Here we're saying there exists some x such that 1x isn't equal to x. Now that's clearly untrue. What would you have to do to prove it was untrue? You'd have to show that for all x, in fact, 1x is not equal to x. There exists x such that 1x... Oh, this is clearly true. I just talked complete rubbish. It's clearly true that there exists an x such that 1x equals to x. So the negation is that for all x, 1x is not equal to x. Because that's what you'd have to do to prove that that was untrue. So for all x in R, 1x is not equal to x. Oh, now this is where I'm trying to trick you, and I've almost succeeded in tricking myself, because there isn't one that says exactly that. But another way of saying this is x is in R implies that 1x is not equal to x. So that is C. And now by process of elimination, you can work out what the sixth one is, but it's just as well to check to make sure that we've done the right thing. So the last one is, there exists x in R such that x times 0 equals 0. So how do we negate it? We turn the exists into a for all, and then we negate the last part. We get x0 is not equal to 0. And then we use our brains a little bit and we say, what does this actually mean? It means there exists an x such that x0 equals 0. Well, that's true. To show that it was untrue, you'd have to show that for all x in R, it was untrue, that x0 is not equal to 0. And so if we look at our piece of paper, we discover that this is A. All right? So the important thing to remember about negation is that if you're told that something is true for all something or others, and you want to prove them wrong, all you have to do is find one place where it's wrong, which is why for alls turn into exists. And if you are told that there exists an x such that something or other is true, to show that that's wrong, you have to show that it's wrong for all x's, which is why when you see an exists, it turns into a for all. That's the end of that question.